gentlemen, hello. This is the beginning of part 3 of the 96 pill rebuild. We're going to continue on. It's changed a little bit since you guys have seen it last. I wanted to get to this point. I wanted to be able to just get to this point. This is my favorite part. Now we get to put the 12 volt lead in this thing. So, we're looking at pure money. This is 4/0 gauge wire. This is the same as running 4 leads of 1/0 gauge cable. This high temp, oil resistant, high strand count, oxygen free copper for 20 feet of it is 150 bucks. So there's about 6 foot of wire here. And we're looking at $70 just on this one side. We're going to have 4 of these leads bringing the current, the 12 volt positive side of the current, to the cabinet. Remember, we have to visualize this thing completed. We have a single piece of 4/0 coming down here to the middle of the cabinet. Well, we are totally capitalizing on the fact that the whole cabinet's made of good, thick, heavy-duty aluminum, and it's got multiple attachment points for ground. The L bracket that we run down the entire length of the heatsink, plus the reinforcement bar that went down the middle of the cabinet. This thing here in the middle. It's eaten so much 632 hardware, it's not even funny. It's got a universal ground on it. We're going to hook the ground cables up here on the back of the cabinet, back here. But we have to visualize this with the side plates on it. There's not a lot of metal mass attaching the back of the cabinet to the base of the cabinet, but there will be when we attach the sides. This whole thing is going to be held together with 632 screws, so we can unscrew the side panel and work on it if we need to, or put the panel back on. Novel idea, I know. Well, we have to do the same thing in reverse on the positive side. So I have to provide enough metal mass to where there's not a significant amount of line loss from the back of the cabinet to our power distribution bus. So we're going to have 4/0 leads bringing the current in to these bus bars. Now I floated the bus bars up for a reason. So I had room to run all the wire, and so that I could have all the wire run and still make it so people could get in and work on it if they needed to. I have a feeling, just have a feeling, that this thing might pop another pill in its lifetime. Just saying. Hopefully not. It might. Probably. Most likely will. So we gotta leave ourselves open to be able to have access to everything in here. I had an interesting conversation with the owner of the amplifier yesterday. He called me after I sent him pictures of this, and he's like, well, is there a way that we can make the blower fed by a different source? And I said, why? He goes, well, I just don't know if that blower is going to be able to keep up or not. And I said, why? Do you think there's going to be a current restraint? He goes, well, when I key down, if the voltage drops way down, I don't want the blower to stop turning. I said, but if the voltage drops way down, that means you need either more alternator, more battery, or you need to increase your lead size going to the back of the cabinet. I told him it's going to need 4 4-gauge wires for ground and 4 4/0 wires for ground coming to the back of the cabinet, 2 per side, and then 4 4/0 leads for the positive side. In theory, this 3.5 foot run of wire, and it's hard to tell for scale how big this thing is, but 4.5, almost 5 foot long, this box, right? 4 of these leads will easily carry, what, 600 amps apiece, right? This distance. The idea by having this come to the front of the cabinet and our ground being universal is that the positive leads, when we take, and if we were to take these pedestals off and hang it up in the air, you'll see that all the 12 volt runs that I'm going to put in here are going to be the same length. So there's going to be the same amount of electrical resistance from this plate from here to these back sections as it's going to be the same distance of wire from this plate here to the front sections. We do that so that not one section gets more current than the other. We have to make sure that everything inside this amp runs the same. This section puts out the same as this section, and this section put out the same as this section, and so on. And how we control that is by making sure everything has a measured amount of equal current that it has access to. The way this was set up before is it had a pair of twisted 12 gauge copper leads that came off the center of each 8-pill section and then went over to a single piece of 1/0 gauge wire and ran down the edge of the cabinet. Remember, we were running off two 300 amp Anderson clips for 2,500 amps worth of load. My customer is used to the fact that when he keys this box down, the fan almost stops because there's not enough energy making it into the cabinet to run the blower, which is going to sit on top as an auxiliary fan. That 5 amps that it takes to run the blower, there's too much voltage dip. I said, dude, this is going to be a completely different animal. He's not visualizing it. I can tell. He's like, okay, I don't think so, but okay. And I'm going, well, dude, we're not using Anderson clips anymore. If anything, he'd want to use twist lock leads, but there should be 8 total pieces of 4/0 gauge wire coming to the back of this thing, with hydraulically crimped and soldered eyelets on it. All the eyelets in this box on the inside of it are hydraulically crimped. Then we drill out the end of the eyelet and we backfill it with solder. And it fills up just the tip of the eyelet with solder. There's no leakage that goes back up the wire. We just fill up the tip. So we're grabbing the ends of the strands. When you go to crimp this, it creates a cold weld, 100% connection. But on the other side, there's an air pocket, and we utilize that to give ourselves an electrical connection. It lowers the resistance even further in the eyelet. I don't care what anybody says. I don't. After all my years of doing car audio and all my mobile installs and all the crap I've done in my life, I'm here to tell you, hydraulically crimping the eyelet, you are leaving amperage, and increasing the resistance, you're leaving amperage on the table. I've had eyelets that have gotten smoking hot. Now that we got a FLIR, we can visually see the eyelet. Oh, the eyelet's hot. And that's with a good solid hydraulic crimp. Eyelet still gets hot. We come back and we drill a hole, we fill the eyelet full of solder at the end. All of a sudden the eyelet's not hot anymore because it can carry more shit. It's got a lower electrical resistance. The cold weld's got a fairly decent electrical connection to it. I'm sure there's somebody that's going to make a comment down the doobly-doo that I'm smoking crack gonorrhea herphosyphilades and I don't know what I'm talking about. I'm telling you, that makes a huge difference in how the eyelet works. I got a friend of mine. He's into the mobile RV off-grid solar systems. He brought his trailer over here and we installed all the shit in his trailer. And he went and he ran that trailer and his connectors were getting hot. I said, well, I told you. So he brought it back over here. We fired up the solder pot and drilled holes in all the eyelets and just went and submerged dipped all the eyelets because they were all 4/0. All the heating issues went away in his trailer, and all of a sudden everything went up in efficiency factor by like 15 or 20%. And he was like, ooh, and I'm like, dude, I'm telling you. Most people that sit around and they squabble about this, they've never put together heavy amperage, low voltage connections. There's a lot of electrician friends that I have that think I'm crazy because I backfill that eyelet with solder. No, we've got hydraulic crimpers and we crimp it like 3 times. And yeah, but you're also talking commercial 3-phase or 220 volts and voltage is higher and it's AC signal, not a DC signal. There's differences. And everybody's got to pull up the little 1960s NASA study about soldered eyelet connections. That's great. The main problem that's pointed out in that study, which I've read, is when the solder goes past the eyelet and into the wire strand itself and it makes the wire strand hard. There's a breaking issue that can take place where the wire and the eyelet come together because the joint's so stiff. Well, we mitigate that with marine grade heat shrink, but if you do your crimp properly, there is no solder leakage from the front of the eyelet into the wire. So there's no... The study does not talk about the current loss in the eyelet at all. Doesn't even address it, but everybody throws that up as their argument standard, and I just laugh and go, ah, you children, so funny, and I move on. Needless to say, the idea is that every wire that I'm going to put in here, the 12 volt positive, is going to have the same length to it. So we're going to have a common feed point, and even though we're going to have to do some creative looping with the wire that's going from out here to this panel over here, or out here to this panel over here, is going to be the same electrical length as the wire that attaches here and goes to here. We just slack it up in the cabinet. So that way everything has to go the same distance and everything gets the same amount of current. Makes sense? Same amount of electrical shmoo. I brought it over here because we've done such a good job of cleaning this amplifier up. The only thing that's left to wire on this is the 12 volt lead. And it's not a spaghetti mess on the inside compared to what we started with, right? Everything's uniform, everything's even. It's got even electrical potential throughout the cabinet, and it will have that on the 12 volt side. So that's what we're going to work on now. Let me bring you in here so we can see what I got going on here. So we got our dual 4-aught cables coming down to this piece of phenolic. Now, can this piece of phenolic handle 1350 amps? No, hell no. No. There's probably less copper on this board than there is in half of a penny. Okay? What we capitalize on is that we're going to put a thick layer of solder on this, and then the distance from this connection point to the wires is so small, and the metal mass that we're going to provide it is so significant, we don't have to worry about any electrical resistance or coming apart, right? So to bond these two internally, because anytime you have a split connection, like on the inside of a Texas Star 667, or you have independent positive leads, anytime that you have the opportunity to where, let's say, maybe this eyelet comes loose back here, because this, remember, this is going to be mirrored. This, and the same thing going on over here. Internally, inside the amp for safety issues, we have to make sure that we have the ability to deliver current to both sides of the amp. So let's say this eyelet becomes loose. Well, yeah, all the electrical shmoo is now trying to go down through this wire, but that's way better than having half the amp with no current on it. So, once again, took a nice heavy-duty piece of copper between the two, gave it about 1.5 inches worth of overlay on each one of the boards and soldered this down. This is in here. Just in case, for some reason externally, the eyelet on this side comes disconnected, we don't end up frying half the box, because half the box shuts off because it doesn't have any current. We have to tie it together internally. I wish I would have had enough 4-aught. I honestly thought I had enough 4-aught to pull this entire project off. I was a little bit disappointed in myself when I went to pull the power wire out and I went, oh my God, I don't have enough. That has been the story of this entire box. I don't have enough of this. I don't have enough of that. I got more RG400 coming. It's in the mail now. I got, dude, the amount of 100 ohm resistors in this son of a bitch. Let's see, there's 98 above the transistors alone. So there's 3, 6, 9, 12. So 24, 48, 200 plus 5 watt, 100 ohm resistors in this thing. 110 ohmers. Just goes on and on and on. And on and on and on. And on. And on. All right. Welcome to part 3. Part 3 is going to show us finishing this amp out, us hooking it up and running and testing it. I will be testing this thing by the end of the day. I'll be hooking it up with a single piece of 1-aught gauge cable, positive and ground, just enough to turn it on, and I want to see all the transistors light, and I want to check to make sure none of the stages are dragging or dragging down. They're all performing roughly the same. It'll allow me to start playing with the tuning, and I'll probably just put a couple 100 watts in this thing, if that, just to see the thing run. But the goal is to get this thing finished in part 4, get the big monster power supply installed, which now I've got to build another one because the customer that is doing this amp. He wants another one, not like what mine is, but something that's a little bit more modular. He wanted to actually buy that supply, and I said, no, dude, I built that for me. His, I got to build differently. So, you'll see. We'll see. You'll see. There's going to be a video of that coming out here pretty quick. Because I have got to go deliver this. Because I want to put this in Homeboy's truck, and I want to watch it run in his truck. This is too big, too much money, and too big of a pain in the ass to have this flying back and forth via shipping. So, this is one of these things I got to go hand deliver. Alright, let's get on with the power wire install. So how this works out is 12 pieces of 8 gauge per side. So, there's, between what's here and here, 24 pieces of 8 gauge that are all the same length to go in here for the distribution. So we'll count off 1, 2, 3, 4, 5, 6, 7, 8. Recount 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 per side. There's 6 sections, 2 pieces of 8 gauge per stage or section, however you want to refer to it. Now, if we were to take the sum total of 12 leads here and measure these, like strip these all back and so they all had the same, and measured it, you would find that there is slightly more wire in these 2 pieces of 4/0 than there are here. So we carry more current to here, and then we split it evenly amongst all these sections. So down the middle of this thing, we're going to have, what? 2, 4, 6, 8. So we're going to have 16 pieces of wire going this direction. And then 2, 4, 6, 8, 8 going back this way. If that makes sense. But they're all electrically the same length. I go over this, and I go over this, and I go over this when I talk about power supplies. I'm on my 3rd roll of solder. $12, $14 per roll. This 8 gauge wire, this roll of 8 gauge wire, cost me $330. The roll of 4 gauge, like I said in the previous segment, $146 times 2, so that's $300, right? Each one of the bronze bolts at the back of the cabinet. The bronze bolt, the washer, the second washer, the second nut, the 3rd washer, the 4th washer, the second nut, the 5th washer, the bronze lock washer, and then the bronze nut that's on the outside to go onto the bolt to bring this into the cabinet. There's $15 worth of hardware right here, if not more. Not to count the eyelet. I mean, there's like $800 worth of wire in this cabinet alone. I want you to think of how much Teflon wire I used to rewrap all of these toroids so they're all new. And then all the distribution panels that are in here. Then all the 316, the RG400 at freaking $2 a foot or whatever it costs. There's a lot of money going in this box. A lot. But that's to make it right. And by the time it's said and done, it's going to look really cool. It's going to be very organized. We'll have access to all the transistors and all the components. We can add capacitance if we need to. I have a very sneaking suspicion I'm going to have to add capacitance here, and down here, and over here, and over here, and over there. And the same thing, add capacitance here, here, and here, and here. Just have a feeling. So we got to leave this open so that we can get in here and do what we got to go do, right? Just planning ahead. Just got to plan ahead. I don't care how I put this together. It's going to look way better than what we started with. No ifs, ands, or buts. Frickin' spaghetti nightmare. Ba-da-ba-dum-bow-bow. So this has changed a little bit since you guys have seen this last. I God, it's nice to be able to stand up and move around. Working pretty steady here the last 2 days, and we're 99% there. Major things I got left to do is to add the blower to the top, which I'll probably do that tomorrow. But the box is done. It looks freaking awesome, in my opinion. This is all held together with 632, an aluminum angle that has been drilled, tapped by hand. By hand. So I'm going to say this to the guy that owns this amp. You will only put the screws in by hand. Don't use your Roy Fucky, DeWilty, Milfucky screw gun. Don't do it. Just put the screws in by hand if you've got to open this up. It's also changed on the inside. This is 99% of the finished product is now done on the inside of this. I've yet to hook this up and run it, so I'm sure there's going to be some capacitance that I've got to add, but this turned out really nice on the inside. Set this panel over here where it's not going to get bumped into or scratched. And grab my screw of the driver. So I want to undo this side first. Screwdriver by hand. Go. Stay. Ubu. Stay. Okay. So I call this the butterfly. I've had the people on Patreon. Of course, if you are a Patreon subscriber, you get to see what I do every day. Up to date, up to minute, every day. They've gotten to see this already. Had Chad Jolie at Donkey Stomper. He's a Patreon. He goes, man, that's a lot of 8 gauge. And I said, yeah, Chad, the problem is that the wire that comes from this end of the cabinet and the wire that goes to this end of the cabinet all have to be the same length. So obviously the wires here, wires here, wires here, and wires here, there's going to be a little bit of excess. Well, me being me, I play to that. So this wire from here goes to here, and this wire from out here goes to here, and vice versa, all the way up to this one here goes to here, and this one here goes to here, this one here, and this one here, and so on and so on and so on. It looks really cool. Even had one guy refer to this as a vulva. Of course, that's not the words he used, but you can kind of see it. I mean, if we had we're asking each one of these 4-aught lead or 4-aught gauge wires to carry 625 amps max. And if this guy runs this amp smartly, we're not going to have any problems. We elevated the stand so we could get airflow on both sides of the board, top and bottom. That way there should not be any kind of heating issue where shit comes unsoldered. But this is it. Front, back, sides, top, bottom, all fabbed in-house. All of this fabbed in-house by hand. It's freaking neat. Freaking neat. I guess the next thing that we're going to do is we're going to go over here to the dual line section. I'm going to put a PL259 connector on it to start. I'm going to just hook it up to the workbench power supply. And I'm going to start twiddly farting with it. Keying it up. Seeing if we got any sections that are running lower than the others. It would not surprise me that I'm going to have a little piece of solder flick here, or a little piece of wire there, or maybe 1 or 2 things might not have gotten soldered down, or maybe there might be a broken wire someplace, or a cap that is not quite right. We'll find all that out in the next stage. But we're going to conclude this amp with running it off the 2,500 amp power supply and running this thing pretty heavy. This turned out nuts. This turned out craziness. But electrically, spot on. Lots of room for air to move around all the parts. Everything's supported and held up. These little L brackets that are here, it's the same that's over here. They come up, they make a 90 degree, and then they make another 90 degree. So the wire is literally sitting on a copper support stanchion here to help support the wire from up here. Because this 4/0 is fairly heavy. Yeah. I'm satisfied. I'm satisfied. I mean, pass-through tune is pass-through tune, right? So this is the RF's ability to pass through the amplifier across frequency. It's a 1.149. So the RF comes out of here, travels down the coax, goes through the relay, goes through the dual line section. Let me stick my fingers inside the line section. Goes through the line section and out to the dummy load. Needless to say, we can talk through the amp. How we did this simple trick of radio engineering, is down here off the relay, we added a 50 puff off this white wire down there. We added a 50 picofarad metal clad capacitor. So the few thousand watts that fly past or through this amplifier will make it to the antenna when the amplifier's off with little to no problem. Gotta remember, this works both ways, boys. If the RF can go through and come out, that means it can come from in the antenna, down from the antenna to your receiver. But what do I know? All right, we're currently hot. There's 12 volts all on this whole thing. And the only arcing and sparking we had came off of the pedestal over here, where there was a little tiny piece of SATA between the pedestal leg and the 12 volt hot portion of the plate, which that makes me happy. So the next thing we're going to check is the relay, which is over here on the back wall, and all that's for is to run the blower motor and activate our keying circuit. This relay is isolated unless that relay is on. So when you turn your remote switch on, the only thing you're doing is you're carrying enough current and voltage to activate the relay instead of trying to carry the current and the voltage for the fan and everything else. So it makes the pressure that's on the relay very small for like the foot pedal and for the on-off switch. Let's test all of that. Okay, so got the amp on and keyed up at the moment. So now we're playing a game called Chase the Heat. Chase the Heat, hello, audio. So we can see this resistor is out of balance. This one here, okay? And also we can see that the imbalance is coming from this side, this side of the resistor. Well, I, being me, and this is not my first time at the Dog and Pony Show, you'll notice that each one of these pieces of coax has now got a color code on it. I did that intentionally. Both sides have got it, input and output. So over here, you can't see it just off camera, is black and red. Well, black and red on the output side is over here. Black and red. So then we go and chase the heat again. So, come over here. And we know that it's going to be in this row of combiners. So because we bothered to put resistors on everything, so it's electrically correct, go. Okay. This combiner and this resistor is getting hot. So now, because we've planned ahead, and we knew that this thing was going to be an abortion nightmare. Oh my God, what the hell? We can chase it. We know we can automatically eliminate all of these other parts, and we know that we're down to this bank of 8. So now we'll go and we'll look at the resistor either here or the resistor here. Hello, nope, not that one. Hello, okay. So this resistor here is getting hot. So now we know our imbalance is in these 4 transistors right here. There's a flick of shmoo, something not soldered right, broken wire, something in these 8 transistors. Now you ask yourself, how much drive am I putting into this thing? Not enough to even turn on the transistor structure. I'm using the Striker derail 955. So let's see, what does that work out to be? Let's do some quick mathematics here. We'll say 100 watts while we're at 12 volts. So it's 80 watts divided by 96. So each transistor is seeing less than a watt. Now we haven't done the input tune. We haven't messed around with the output tune. I would say less than 1/4 of a watt is making it to each one of these transistors in that 4-pil section, which is fine. It makes it safe. But it has taken me 10 times longer to explain all this to you guys, just so you know what I'm doing, than what it would have taken to find the problem. So now what I do is I sit here and I'll look at all of these parts. Make sure the transformer's down, make sure my splitter circuit, none of the wires are busted off, make sure nothing's broken, disconnected, didn't get soldered up. All of those things, we can quickly bang through each one of the sections. We do this for organization's sake. I learned a million years ago, okay, maybe 7 or 8, it dawned on me that when you have a large lump of coax like this, I could spend 2 hours trying to figure out where this goes. Or I could just color code the coaxes before I, put them in here. And if you don't want to let your customer know, you just come along with a razor knife and cut the heat shrink off. I'm going to leave the heat shrink on. Just makes it easier. We'll unkey the relay because this is not a continuous duty relay. This here. And we'll go ahead and we'll shut the amp off. That is a continuous duty relay. I'm going to get over here and I'm going to start looking. And I bet you anything, I'll find that either a capacitor's not soldered down all the way, or there's some shit that's shorting something out and it's pulling this 4-pil section down to ground. And it's causing the imbalance back here. Just by chasing the heat. Quick, easy, bing, bang, boom. Well, that didn't take long to figure out. Hundreds and hundreds of parts I've had to unsolder and solder down. Look right there. There's solder on the tab of that transistor, but it is not hooked up. There's nothing touching that. This is our 4-pil section. This one transistor, that leg right there, is not soldered down. So let's disconnect our 12 volt. We'll take our soldering iron and we'll put some more magic pixie shmoo on here. And I think that'll solve our imbalance problem. Then we can go on and start tuning things. But this is making power, just not very much yet. Give me a minute. So, I thought, I'm sitting here keying the amp, and I thought, let's hook up this blower and see how bad A it is. This thing is some weak ass sauce, man. And I mean weak sauce. So I propose that we use this. I had this sitting around for years. This is on 15 volts. This thing is half the size. But here's the deal, it's brand new, number one. Oh shit, it's trying to eat my shirt. It's trying to eat my shirt. This thing moves like 3 times the amount of air this weak ass piece of shit's just trying to move. And it's smaller. Well, ballast resistor setup, but this is the weakest shit I've ever seen for something this big. And it's broken. Unplug this pile of crap. Click, 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 click. Yeah. I wonder which direction you think I'm gonna go. Jeez, I wonder. Oh, 2 days. It's taken me 2 days to get to this point. Everything hurts. I just got done getting everything run for this test. Let's back up here a little bit. My workbench is so dusty, and everything here is so dirty. There's little pieces of metal on everything from fabbing up this box. I released a picture earlier today on Patreon before I took everything off the workbench, and I had the 96 pill and the 2500 amp power supply that's now mounted underneath the bench. I had them kind of cropped in the same photo, and the comments that I've been getting have been priceless. Like, oh my god, I can't remember the 2500 amp power supply. These wires are so messed up. That 2500 amp power supply is built in a 64 pill cabinet. Well, that 64 pill cabinet looks like a little tiny kid toy. Good enough. We're just gonna melt the shit out of them anyhow. Looks like a little tiny kid toy next to that 96 pill cabinet. So, everybody's like, I didn't understand it. How big that friggin' amp is. It's big. Big. It's big. Okay, let's put this son of a gun to a test here real quick. So, got our hot and our negative wires here hooked up to the voltmeter, going directly to the distribution bus. Okay. So let's go ahead, we'll turn on the power supply down here. 24 volt setting for some reason. We're at 15.82. Zoom in here so you guys can see what's going on a little bit better. On the top is volts, on the bottom is amps. That's 1,000 amps at 14.8 with no problem. It's mad. It's mad. Okay, so this pile we know maxed out about 1,800 and some amps. Okay, so no problems. Let's recrop and let's take a look at the front of the power supply. So we're looking at meter shunt number 1, meter shunt number 2. And if you don't understand how this is wired, please refer back to video number 1 in this series. And let's see what we can put on this for a load. That's over 2,000 amps worth of load. And it's murder in this frickin' the carbon pile. So now we'll go over here. We'll take a look at these 3 meters. This is my incoming line voltages, represented in AC volts, and that's the power supply voltage, represented in DC volts, obviously. So let's go ahead and we'll load this over to about, oh, I don't know, 2,000 plus amps. You can see we have little to no line sag. To achieve that, we are having to put, this thing was powered, or has, 3 runs of 1/0 gauge cable. 2 hot, 1 return. Crimped, soldered, whole 9 yards, to a separate 200 amp disconnect drop that we put in today, or yesterday. It's, I mean, look at that. The voltage doesn't even move on the lines. So there's 16, 17, 18, 1900, 2000 pegged in the corner. Oh. Oh, oh, oh. Fire. We have burned up the voltmeter inside the carbon pile. It has melted down. The wires got too hot and melted through. All right, let me deal with the smoke. Hold on. You might have overdone it. Oh well, effing send it. Let's get this off of all of our coaxes. Oh, that stinks. Oh, that stinks. Might have overdone it, just did a bit. Power supply's fine, it doesn't care. Carbon pile leads are done though. Refried dog shit now. Oh well, the carbon pile portion of it still works. I have to redo these some other day. Needless to say, I think the power supply is working. Why do I feel like there should be a Star Wars reference right about now?
This station is now the ultimate power in the universe. I suggest we use it.
Don't be too proud of this technological terror you've constructed.
So I couldn't help myself. I had to do a little bit of a post-mortem on the inside of this thing. This material here, which is nothing more than some maybe copper and nickel, is our shunt material. So even though the wires turned into refried dog poop, what happened is our meter shunt literally melted in half. And then it looks like in a violent fashion. So, oh cool, it's got a trim adjustment on it. Let's modify this. Hold on a second. I'm going to start this segment out by saying never be afraid to ask for help, right? And then I'm going to show you the solution that was presented to me, which is brilliant. And I can't wait to tell you guys what happened here. So I go to run the amp. I've got it all hooked up. Big power supply is all hooked up, right? I go to run this thing and start tuning it out. Well, my brain went one way. And what it should have done, I zigged when I should have zagged. So I start running this, and the output combiner showed me that I had a problem in one of my sections. It showed me heat, right? Well, as you guys know, I've color coded each one of these sections. So this 16 pill section is red and black, vice versa over there. So I immediately knew where to come look. Now, I start looking at this section, and I notice that this resistor is now a little bit discolored. Now, I was driving this with a 4 pill and a striker radio. So I was putting about 800 peak in it, maybe 250 bird, right? On the output side, the whole box in total was producing 6,500 watts, or 6,000 watts, and about 2,800 to 3,000 bird. It's a little low. So I knew I had a section that was dragging. Well, I come back over to this final section here, and these resistors aren't getting hot, so that tells me this whole section's working really fine, okay? But this resistor's getting hot. This resistor was getting hot, this one was getting hot, and this one was staying ice cold. This is when my brain zigged when it should have zagged. It's 3:30 in the morning. I finally am around to where I can get this thing to where it's going to go, and I start looking at it, and I'm thinking, oh, and let me just tell you, where are we going, camera? Where are we going, camera? Let's stay here. Let me lock this down. My brain starts thinking, because I've had so many broken wires. I spent probably 2.5 hours yesterday making sure that these leads coming out of each one of the transformers, because over on this section here, I had 2 wires that were broken coming out of the output transformers. So then that means I had to go and inspect every single one of these and resolder about half of them in the box. I start looking at them, a little bit scuzzy. Let's just redo them, plan for the future, right? So this section's dragging. My brain is telling me now, because I'm hardwired in this mode, to think broken, disconnected, or bad, right? I couldn't find anything here on the output stage. And I'm like, why isn't the RF wanting to go from here to there? Now I'm measuring with the oscilloscope at this point, each one of the sections. And I finally said, piss on it. I'm tired. I'm going to stop. I've had these pills out now twice to check each one of them, and they're all good. My brain's telling me, well, normally in the past when I've seen this, if I have one here and this isn't getting hot, that means these stages aren't working, that stage isn't working, and no RF's making it here, so there's no reason to see any imbalance because it's not getting hot. But yet, we got 8 transistors here that are imbalanced over here. That's why we're seeing this resistor get hot. So I finally get around to where I can start working on this today. And I call my very good... Sorry about that, you all. I just kicked the tripod. Batteries come flying off camera. Tell I'm a little discombobulated from working on this thing. I got this thing sitting up on a camera tripod, hanging half off my workbench, so I've got room to move in here. I'm pretty discombobulated, so I called my friend Terry, and yes, I'm talking about the grumpy old hermit on the hill, Terry 55. I said, Terry, give me some different options. He goes, well, the only time I've ever seen that happen is when you've got something causing this stage not to fire and that stage not to fire that are independent of each other. I'm like, Terry, I don't know what it could be. I don't know what it could be. I've tested this and tested that. And he goes, slow down, go back and look at it again. So let me show you the problem that we're having. Hold on. I need a bigger boat. Need a bigger boat. Let's start here. So I go and I pull my first 680 off, And that's what the capacitance meter shows me. This 680 output cap is completely shorted. Garbage. This output cap here has a reading of 512 picofarad. This capacitor here has a reading of 575 picofarad. This capacitor here has a reading of 205 or 210, whatever it was. This being a dead short. Hence the reason why this whole section over here, right here, is getting hotter than an atomic firecracker and the whole thing's dragging down. Now let's step back and let's think about this from the 16 million feet up in the air, 6,000 feet up in the air, eye in the sky. I tested a large majority of these caps. If we go look at, let's just use this one for an example here. Pan the camera over. We're going to zoom in down here. If we go look at this cap here, you can see the whole ass end of this thing has been knocked out and beat up and pushed out. So I know when I go to pull this off, it's going to be out of spec. When I start going through the amp, there's probably about another half dozen that are just like that. They are beat to death. Too many fingers been in the pie over the years, and they're scuffed off like this here. This one right here. The thing's a mess. So back to my initial problem. Normally this wouldn't be that big of a deal. I went and scoured the internet a little bit today, and 680 is a little bit of a tough number to come across in metal clad anymore. Well, metal clads in general. So I started thinking, well, now I'm up to 4 that I have to replace. Look, I got to drag this thing all the way across the United States. It's too big to ship back and forth. I mean, it's not really too big, but I'd rather be safe than sorry. Most capacitors have a tolerance window of 10%. Well, actually that works out to be 20%. So 20% high and 20% low. Or 10% high, 10% low, 20% window. This is a 1000 puff metal. If I put 1000 puffs in the amp over here, I'm losing probably 20% of my watts per section across the board, and it's going to make it run really, really hot. Amp's going to run really hot. It's going to pull a ton of current just by changing out these 680s and going to 1000. My friend Terry says to me, he goes, well, make your own cap. I'm like, Terry, I don't want to do that. He goes, make your own cap, young man. I went, oh, Terry, you got me thinking. And then I told him to promptly go F himself because he's so much smarter than the most people, right? Sometimes it just takes another point of view to help you understand where you need to go on your next step, right? You need to consult a peer. The problem is in this community, a lot of people aren't willing to humble themselves to try and help each other, or they're deathly afraid to say they don't know. I am so over the barrel on this box when it comes to time. I'm just on and on and on and on and on. I'm over the barrel. I just got to get it done and then move on to the next project and recoup my losses and go lick my wounds in the corner quietly, you know what I mean? So that 20% tolerance that we were just talking about, I would rather be, I don't know. Let's see here. What is the difference? 738 minus 680. I'd rather be 50 picofarads high than dead short and low and possibly could fail in the future and the guy's got to send the amp back. 50 puff is not that bad. I can compensate for that elsewhere in the circuit in the output tuning network. So this is a bag of 1% metals. They cost $7 to $9 a piece. I've now got to modify 48 of these, which is not that hard. It's when you take one of these things apart, this is what the inside of them, one of them looks like. You got a leg, another leg, right? This is what one of the insulating wafers look like. Come here. Insulating wafer, another leg, and more insulating layers that are all packed together. All I have to do to get the 738 or 740 puff is pull one leg out and then recrimp the edges very carefully. I have to do that 48 times and measure it. And then I have to go and pull 48 scuzz bucket transistors out of this thing, or capacitors out of this thing, these, and then replace them with brand new bent and crimped and tinned caps. I want you to think about how much of the original amp is actually left. None of the power wire, none of the coaxes, none of the combiner, the splitter network. This is the only bit of the input network that's left. The flyback resistors have all been changed. The 120 puff capacitors, I might as well have changed all of them because I pulled all of them and double checked that they were actually what they were, because I found 220 and I found 320 capacitors as I did that. Checked all the 10 ohm resistors. I want you to think about this. Pretty much the only thing that's left is the heatsink, the board, and the transformers. If I was a bitching kind of guy, I would say I want a raise. So the moral of the story is no one can know all of it. Do not ever be afraid to call and ask for help. Don't ever be afraid to say, I don't know. There is no such thing as a dumb question. And thank you, Terry, for helping put my head right and put me right back on the right path where I needed to be, because I was going down a rabbit hole that I didn't need to go down. And thank you for pulling my head out of my ass. And do not be afraid to give credit where credit is due. Period. There are a lot of amp builders in this business that run around beating their chests like freaking idiots, acting like they know it all. Oh, I did this, and I was there when that happened. La, 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 and Dave did it first. And blah, blah, blah. Man, stop that shit. It's time for all of us to grow up a little bit. I know you all are watching, because there's quite a few that are. I've heard the comments. Man, I'm watching this rebuild. This is going to be interesting to watch. La, 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 la. Got it. Never be afraid to ask for help. Never be afraid to say you don't know. There is no such thing as a stupid question, and it is good to talk to your peers as long as your peers are humble and respectful to you in return. And you are humble and respectful to other people when they call you for help. I gotta go to work. 48. This one came up low, and then the original one that I took apart to figure out how to do this. Done. Now I got to bend all the legs on all 48 of these parts. I got to remeasure and retest, recertify each one of them after bending each one of the legs. Tin each one of the legs. Go in and remove all 44 capacitors that are in this thing, and replace them with these. It all looks fun on video until you actually have to do the work, right? Okay, so this is what the capacitor should look like, physically examining it from the outside. It should look something like this. I have to put that down and put it back in its special little place. This is the one that I was just saying, hey, there might be a problem just by visually inspecting it. I don't know how that cap is still working. This was in this amp. If I hook this cap up and I test it, it reads 524.2 picofarads. Okay. This cap here would fall into this category here. All of these caps on the top side of this paper all fall in the 500 and below. These are in the 640. These are the good ones, by the way. These are in the 649 picofarad down to 500 realm, right? These down here. These are our good capacitors. All right. These are 400s down to zeros. I have one that literally reads 1.1 picofarad. Remember this cap that I just showed you as a visual example of what we were looking for? It reads 0.383 ohms. It's completely shorted out and burned up on the inside. This is the one that initially led me down the Primrose path of problems, is this cap here. We know it's shorted. These are 500 down to 400. These are actually what I would consider almost usable. These are the 680s through 650s. These are well out of tolerance. All of these, they fall into the same clump, which is 650 through 500. None of these would be acceptable, but these are our good ones. These are on their way to the grave, very close to them. These are the best ones out of the pile. These are obviously 2 seconds away from blowing, and these are blown. I pulled about 5 or 6 out of that amp, and by magic I got a mix of this stuff here, that top 2 pieces of paper. So these could cause lots of problems, right? So now everything's been replaced. We've got 720 through 745 or 750 puff throughout. These are all tested, and they've all been tested after we bent them, after we soldered them. I know what I got going on now. We're set. So we've changed the input capacitors, the output capacitors. All the 120s have physically been checked. All the 10 ohms have physically been removed, or checked one leg of them at least and measured. The windings in this whole section of the box had to be rewound because they were so solder screwed up. Well, it wasn't so much easier just to start over, but didn't want to pay that big bill. So he's going to get a big bill for labor. Right. You think this has taken most of a day to pull these, test these, diagnose these, if not more, because I spent how many hours the other day? 3 or 4 dicking around with the same situation. The reason I want to point this out is because I know my customers are going to be like, well, give me back all those 680 caps. Well, what for? Because he said this already. Well, I might want to use it on something else. These all need to go in the trash. They do. There's no use for these ever again. But I have to document it so the customer understands. You follow my train of thought? All right, I'm going to fire this thing up. And we're going to start tuning it now and see if we've got any other issues in any of the other stages, because there could be a little glob of solder, yet still an unfound broken wire. We're going to continue on. It's not too bad. This one ground wire here was at 180 something degrees just a few minutes ago. Okay, so we're running the Striker 955, derail Striker 955 into my bench 4 pill. That comes out, goes past this 50 watt element. Okay. 50 watt slug in reverse. We're gonna see, so this is we're reading this middle scale. We'll see about a box worth of input reflect, almost nothing. This amplifier produces about 1200 watts. We've all seen that on video many, many times. Okay, over here we have our totally never changing 5 watt slug in reverse. I remember when the guy said, oh man, the reason his meters are reading the way they do is because he's got so much reflect from his dummy load. It's a 5-watt slug and reverse back from the Bird 10,000 watt dummy load. We're going to overload that a little bit here in a minute. That's a 5,000 watt slug, and whatever you guys want to call it, Bird, Peak. I had a guy call me the other day, and we had a 40-minute long conversation about, he's a real stickler for information when it comes to reading things in manuals. And long conversation about bird meters, and I'm like, dude, I can't do that argument anymore. It's literally whatever you want to call it, Bird, RMS, whatever, I don't care. Over here is a 25 kW slug reading in forward. Now, I want to put this all in perspective. We are on a PL259 connector, too small. PL259 connector, too small. PL259, 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 PL259. And then down on the Bird, we've got LNC, which is the only connector in this entire measuring setup which is adequately to the size for real-world operation. We have to utilize short keys, right? Like, I'd throw a 10,000 watt carrier out there for a few hot seconds, but I wouldn't want to hold it there. We are also at the max of what we can do with our power wires. So I'm going to cut this off in a minute. When we come back, there's going to be significantly more power wires. There are 2 pieces of 1/0 positive, 2 pieces of 1/0 negative, going to 4 pieces of 1/0 positive and 1 piece of 4/0, and then the cabinet. We don't have the cabinet sides on, we don't have the lid, we don't have any of that stuff. To try and cut down on the RF leakage, I have a Bird 43 blank and another blank in this hole. Well, that's a 1,000 watt slug that come out of that meter in there sideways. So striker into 4 pill, into 96 pill or 98 pill, whatever it is. We're going to see some amazing numbers here in a minute for this little amount of drive. So 1,000, like 1,100, 1,200 watts going in. We're going to be seeing well in excess of 10,000 watts peak. We're not maxed out. We're going to start turning it up from this point on. This whole combiner ring is completely dead. I was having problems before with this resistor heating, which tied into this front corner, which started this whole problem. This resistor heating, which tied into over here. Changing out those caps, all of our problems went away. The thing settled down, it got super quiet, and all of a sudden, I'm telling you, the other day I was running it with the same setup. Okay, and I was having to have doorknobs everywhere. I had 100 puff on each one of the 16 pill sections in the doorknob configuration. Okay, on the input, I also had 100 picofarads worth of capacitance on each one of the 16 pill input splitters to get it to lay down the best I could get out of it with the same configuration on the exact same voltage with 6,000 watts. No more. It was saying, no more. Now it's giving me much more and once more. Amp once more drive. Now, I don't know if I can show this to you or not. The gentleman that owns this amp is really private about his business. He agreed to let me show you guys the rebuild. He agreed to let me show you guys the testing process. I need to make sure it's clear with him for me to show you the end result. Right now, with this amplifier, right here, each transistor in this amplifier is receiving 11.23 watts worth of input power. According to the data sheet, 12 is our max. But we all know that data sheet is in average numbers. So technically we can double down on the drive easily. So this thing needs like an 8-pill driver. I would have to dig out my 2-pill LD MOS amplifier to get there for that drive level on my workbench. I am going to do that. That might be private. Needless to say, this might be the end of the video. As much as I don't want it to be, this might be the end of the video. So we'll see. The phone conversation tomorrow will determine. This RG393 is holding on by the hair of its chinny chin chin. That coax connector right here is holding on by the hair of his chinny chin tin. All of this stuff is just barely hanging in there. And we're going to take it much further. I've taken this much further. I've put that same element in the corner, that one there, in the corner, on video many times. But today, we're going to hit this and quit this. Now, what we got going on here is our amp draw meter. Okay? Our flute clamp over meter. For me to go any further, I've got to put at least 3 more runs of 1/0 gauge cable from this distribution panel to the amplifier, or I need to spend another $159 on 4/0 gauge cable to come from here over to here. We'll have to make those decisions later. We're not doing it now. So on that note, now that you guys got all the backstory, the other thing I want to apologize for is I know RF is going to get into the microphone. It's going to get into the wireless device that you guys are watching this video on right now. It's just going to happen. The cabinet is wide open. We're talking about producing 15,000 some odd watts right now, and you're less than a foot away from the amplifier. It's going to interfere. There's nothing I can do about it. I mean, I'll come back no matter how the decision is made. I'll come back and I'll show the amp running with the same 4-pill and the cabinet all closed up, and you'll notice that all the RF leakage is gone for the most part. But for today, I'm telling you, on the complete other side of this building, probably 55 feet from here, I'm turning on a touch lamp right now. I just know it, because that thing I can fart out here and it turns on a touch lamp. I'm telling you, it's just, it is what it is. So, first off, let's go zip over here. This is just, let's make sure our relay is working. Power supply is off. Let's turn power supply on. Okay, big box relay is working. This is just the 4-pill. Hello, 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 hello. That's how much drive we're putting in it. Hello, 15 grand. Hello, 4,000, no problem. Oh, and of course, this stupid thing, 0. You know, I was toying with the idea of making this power supply with a remote face on it, so I could have yet another set of Bird 43 style meters up here on this workbench someplace, to where we could show the volts and the amps coming out of the power supply, metered from the supply. Hello, audio. Okay. Ready? Hello, audio. Close to 700 amps worth of draw. Hello, 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 hello. 2 boxes worth of input reflag. It's getting there. So we'll go back over here one more time. That's 3,000 watts dead. Hello. We'll pretend like we're an X-Force video. Hello, look at all that swing. Hello, look at all that swing. Let's run this back up here. God, it just wants to go. It's 4,500 watt dead. Hello. So now what we're running into, now that we've just thrown a bunch of big numbers out there for everybody to look at, is everything's starting to get hot. So 1 ground, it's like 80, 90 degrees. Well, over here on the back of the amp, I got the same thing going on at this connector, but it's much, much, much hotter here. So I have to change some stuff. When stuff cools down a little bit, back over to 15,000 watts. Okay. Your power wires to your amplifier matter. All wire gauge matters. Just saying. And I'm keying this with little to no fear because the box is only running at maybe half. Hello. Hello. Hello, 1 2 1 2 1 2 1 2 1 2 1 2 audio 1 2. Nothing's over here smoking. Nothing's even hot. Hello, 1 2 audio. Show it to me, baby. I said under that old Model T was a place she first showed it to me. Big and black, and she called it her crack. You get it? Box is at half. We're at half. Well, this is where we have to stop for now. I'm going to go off and probably make more 1/0 gauge power leads. Like I need more of those, like a hole in the head. At least 2 more for the positive, 2 more for the negative. I'm going to put the side panels on it. And I bet just by putting the side panels on it and allowing the case to have more ground reference, I bet you I'll pick up another 200-300 watts. I don't know, we'll see. Right now I'm happy. I'm super happy that everything is running, nothing is smoking, everything is balanced, and everything is happy. This has taken weeks and weeks and weeks. I'm on my third, 1, 2, 3, 4, 5th week of working on this box. Straight, every day. I'm excited. Needs more drive, needs more drive, needs more drive. So, I got the blower fitted. And there was some questions about if the blower was going to be powerful enough to pressurize this enclosure space. To which I say yes, and I'm going to give you this little demonstration. So, this isn't thin aluminum, this is some fairly massive metal, or not massive, it's decent metal, right? So this screw is tight, and this screw over here is tight. Ready? The whole cabinet is flexing. There is a significant amount of air going through this cabinet. Needless to say, there's more air moving through this enclosure, and there's more air moving across the transistors than have ever been through the heatsink, or across the heatsink. There's more air moving across the heatsink than has ever been done in this amplifier's history. Period. Now, is the RF going to bug the fan, the blower? I put these on 32s and 64s, so I don't know. We'll see. I got a decent choke here on the power cord to the back of the blower. Another one on the inside, so we'll see what happens. I'm going to put the rest of the screws in this thing to keep as much air going through it as possible, and we're going to hit it real quick and see what happens. So the owner of the amp has asked me to keep what the final output is secret. He just wants to maintain his level of security, right? I get that. Audio 1 2. Well, let's turn the drive up a little bit here. Everything catch up. Audio 1 2. That's all I can tell you. But please note, the blower never slowed down. I don't think we'll be able to get this thing hot, to be honest with you. We'd never know. Hello, 1 2 1 2 1 2 audio 1 2 1 2. Hello, 1 2 1 2 1 2 1 2 1 audio 1 2 1 2. Hello, come in 1 2. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2 1 2 1 2 1 2 audio. Hello, 1 2 1 2 1 2 1 2 audio. Head one, head 1, 2. Yeah. So, the downside to this is this lid. I think I'm going to have to put some sound dampening material on the inside of it. Now, what I do need to do is I need to clear the inside of this cabinet, because all of this work that went on the inside of this thing, I don't want it to go to waste. I really don't want it to go to waste. This thing is moving a tremendous amount of air through it. I'm excited. I think I've overcome all the challenges that this box has thrown at me. Whew. Sure looks a lot better. Hello, 1, 2. Oh, hold on. Here we go. All right. Hello, 1, 2, 1, 2, 1, 2. Audio, 1, 2. Hello, 1, 2, 1, 2. Slightly elevated exhaust air temperature. That's a lot of air. And I mean slightly elevated. Okay, I'm happy. Moving on. This feels good. I was able to clean my entire workbench down, rub it down with rubbing alcohol and clean it up. This is called a towel. The reason I think that's funny is because I haven't been able to put a towel down there for quite some time. I've had that giant thing on the bench, so this has bugged me, and I've been tripping on this for over a month now. Let's take this garbage combiner out of here. I'm throwing all of this away. All of those random chunks of friggin' RG400. This is amazing to me. I don't want to necessarily say this is wrong, but I will say that I think that this could have been done differently, right? This is the original output combiner, final stage. Maybe I jumped the gun on putting the towel down. Let's start here. I told you guys I wanted to do an autopsy on this because I'm just fascinated by how somebody thought that this was a good design. And once again, let me reiterate that this amp was full of scab architecture, right? Here, this burned up, so I'll get this running for you. Take it to the local tech, and then he... Okay, so that layer of electrical tape did nothing. He came up with this, right? And then the next thing, he came up with this. And then the next thing, he come up with that. And then the next thing, he come up with this, you know? Scab. Just scab it together. Instead of recognizing the whole thing as bad, they just scab more bad on top of bad, on top of bad, on top of bad. I won't take long here, you guys, I swear. I just wanted to see how this is all put together. Oh, geez. Oh, geez. Holy shnikes, man. So this here was the center conductor that went. This is a piece of 218 with the shield ripped off. And that's what all this copper braid is, by the way, is 213 shield. So this is a piece of 213. This was a ground. But this is what went to the relay. This untuned or untunable length of wire. This is what went to the vacuum variable. This piece of coax, which is not the right way to do things. But hey, what do I know? Wow. I bet you that solder joint has come apart a couple times. These are ground wires. And then these were attached, these connectors here were attached to the each one of the inputs. We'll take apart one side. Then I want to take the center combiner apart. Wow, are you kidding me? This was put together with a blowtorch. Yeah. Okay. So these are the leads off of our combiners, which they've got going like a quarter of an inch from ground. And then they got that going through some zinc hardware, going to an eyelet that was put on by a blowtorch, going down a piece of 217 coax. The combiner final stage is held together with hose clamps. And I'm sure if I take this apart, there's even more wonderful technology in there. Look at that. Whew. This thing has been so heated and is so burnt, I can almost guarantee you this ferrite's no good. The rest of this mess I've got sitting on the floor over here, I'm just going to throw it all in the trash because it's worthless. Unbelievable. Well, gentlemen, I'm done with this project. This has been a long road to hoe, and I want to say thank you to the Patreons. That's 3-hour-plus long videos that you guys have gotten to watch without any YouTube ad interruptions on your phones, on your tablets, whatnot. So let's give thanks to them. I'll give you an update from the road. I will record a video once we get this in the truck and it's running and that kind of thing. I'll try to remember to do that, but gentlemen, this is the end of this video. I want to thank everybody for sitting here and watching this and following this all the way to the very end. The numbers on this project have been just off the scale. I can't say thank you enough. I appreciate everybody's support. I've got about 30 more ROs from last year that I need to do, which that's what I'm going to go turn my attention to now that I'm done with this. So you're going to see me do my bread and butter. 667s, a bunch of Ameritron stuff. I've got A 48 pill I got to jump into here probably next week. I'm going to go get busy because there's no rest for the wicked, and I've had enough time sitting with my thumb in my ass around here waiting to get better. And now that I'm feeling good, it's time to get back to work. If you've ever got a question that I can help you with, don't hesitate to give me a call. I'll do what I can to answer your question. If I can't answer your question, we're going to go find the person that can answer your question, and we'll learn together. So on that note, I want to say thank you, gentlemen, once again, for following along, reaching out, clicking the subscribe button, joining me and helping support the YouTube channel on support the YouTube channel through Patreon. I appreciate every single one of you guys. 2024 is going to be stellar. I'm here to tell you I've got 5 major projects that I'm looking forward to working on already lined up for this year. One of which is a 128 pill transistor amplifier. I've got a big project getting ready to come up. It's just over the horizon. So on that note, gentlemen, I want to say thank you. I appreciate every single one of you guys. It's time to go get busy. Click, click, click.